In this class, let us learn interference. Interference is based on the principle of superposition of waves. According to the principle, when a number of waves traveling through a medium superpose each other, the resultant displacement at any point is the vector sum of the individual displacements. If y1, y2, y3, etc. are the individual displacements, then the resultant displacement y is equal to y1 plus y2 plus y3 plus etc. Therefore, when two light waves of same frequency and having zero or constant phase difference traveling in the same direction superpose each other, the intensity in the region of superposition gets redistributed. At some regions, intensity becomes maximum and some other regions, intensity becomes minimum. This phenomenon is known as interference of light. So let us consider two waves in phase. Let y1 is equal to a cos omega t and y2 is equal to a cos omega t. Both are having same amplitude and same phase. Phase value is omega t. The resultant displacement y is equal to y1 plus y2, which is equal to 2a cos omega t. It is equal to capital A cos omega t, where capital A is the amplitude of the resultant wave, which is equal to 2a. And the intensity is proportional to square of the amplitude, or the intensity of the resultant wave is equal to 4a square, where a square is the intensity of the first wave, which is same as the second wave. Therefore, the resultant intensity is 4 times I0. Thus, the intensity becomes maximum, and this phenomenon is known as constructive interference. Now, let us consider two waves which are out of phase. Let y1 is equal to a cos omega t and y2 is equal to a cos omega t plus pi, a phase difference of pi in between the waves. So, they are said to be out of phase. Cos 180 plus theta is minus cos theta. So, y2 is equal to minus a cos omega t. Therefore, the resultant displacement y is equal to y1 plus y2 is equal to 0. So, the intensity is 0, that is the intensity is minimum, and this is known as destructive interference. So, in the regions of constructive interference, two waves which are in phase superimpose and the resultant amplitude is twice that of the individual waves and the intensity becomes 4 times. In the regions of destructive interference, two waves which are out of phase, that is a crest of one wave, superpose with the trough of the other wave. So, they cancel each other and the resultant displacement is 0 or the intensity is 0. Interference is experimentally demonstrated by Thomas Young, and the experiment is known as Young's double slit experiment. He produced two slits, two sources of light B and C from a single source A. And in this region, the waves from the two sources B and C superpose each other. And the intensity in this region varies from maximum to minimum. At some regions, intensity is maximum, and at some other regions, intensity is minimum. This pattern is known as interference fringes. So, the waves from the two slits superpose each other, and in some direction, two crests or two troughs meet. the solid line represents a crust and a dotted line represents a trough. So in the directions where two crusts or two troughs meet, the waves are in phase and so the intensity is maximum. In some other region, a crust and a trough meet, a solid line and a dotted line superpose each other. Crust of one wave falls on the trough of the other and they cancel each other and the resultant intensity will be minimum. So in this region, the intensity is minimum or a dark fringe is formed. So we can say alternate bright and dark regions or fringes. Now let us say sustained interference. If the interference pattern doesn't change with the time, the interference is said to be sustained. The conditions for sustained interference. The important condition is two sources must be coherent. That is, the sources should emit light waves of same frequency or wavelength and the waves should have zero or constant phase difference. Second one is sources should emit waves continuously. Number 3, amplitudes should be almost equal. Number 4, sources must be narrow. Number 5, sources must be monochromatic. Number 6, the two sources must be close to each other. Now let us derive the expression for resultant intensity at a point. Let us consider two waves meeting at any point P. Let y1 is equal to a1 cos omega t and y2 is equal to a2 cos omega t plus phi, where phi is the phase difference between y1 and y2. The resultant displacement y is equal to y1 plus y2, which is equal to a1 cos omega t plus a2 cos omega t plus phi. This is of the form cos a plus b, which is equal to cos a cos b minus sin a sin b. So the resultant displacement can be written as a1 plus a2 cos phi into cos omega t minus a2 sin omega t sin phi. If phi is constant, a1 plus a2 cos phi is constant. a2 sin phi is also constant. So let us take a1 plus a2 cos phi equal to a cos theta and a2 sin phi equals capital A cos sin theta. Let us substitute in this equation. Then y becomes a cos theta cos omega t minus a sin theta sin omega t, which is equal to a cos omega t plus theta, because this is of the form cos a cos b minus sin a sin b, which is equal to cos a plus b. So from the first two equations, we can find the resultant intensity on squaring and adding 1 and 2. Right hand side becomes a square cos square theta plus a square sin square theta. But cos square theta plus sin square theta is 1. Therefore, a square is equal to a1 plus a2 cos phi the whole square, that is a1 square plus 2a1 a2 cos phi plus a2 square cos square phi plus a2 sin phi the whole square. Again, a2 square cos square phi plus a2 square sin square phi is equal to a2 square, because cos square phi plus sin square phi is 1. Therefore, square of the amplitude, that is the intensity I, is equal to a1 square plus 2a1a2 cos phi plus a2 square. Or I is equal to I1 plus I2 plus 2 root I1 I2 cos phi, where I1 is the intensity of the first wave, which is equal to a1 square, and I2 is the intensity of the second wave, which is equal to a2 square. And a1 is root of I1 and a2 is root of I2. The term 2 root I1 I2 cos phi is called interference term. If phi is constant, the interference will be sustained interference. Now let us see the conditions for constructive and destructive interference. The phase values of a wave can be represented as shown here. A phase difference of 2 pi corresponds to points which are in phase, and a phase difference of pi corresponds to points which are out of phase. The distance between two consecutive crusts or two consecutive troughs is lambda, or that is a path difference between two consecutive crusts and two consecutive troughs. The phase values corresponding to a crust is 90 degree or pi by 2, and that of trough is 270 degree or 3 pi by 2. So the phase difference between two consecutive crusts is 2 pi, or two consecutive troughs is 2 pi, while the phase difference between a crust and a trough is pi. So a crust and a trough, they are said to be out of phase, while two crusts or two troughs, they are in phase. So a phase difference 2 pi corresponds to points which are in phase, and the corresponding path difference is lambda. While a phase difference pi corresponds to points which are out of phase, and the corresponding path difference is lambda by 2. For constructive interference, the intensity should be maximum. So cos phi should be maximum 1. So the phase difference phi should be 0, 2 pi, 4 pi, etc. or 2n pi, where n is equal to 0, 1, 2, 3, etc. And the corresponding path difference is n lambda, because a phase difference 2 pi corresponds to a path difference lambda. For destructive interference, the intensity should be minimum, or cos phi should be minimum, that is minus 1, or phi is equal to pi, 3 pi, 5 pi, etc. Or phi is 2n minus 1 pi, where n equals 1, 2, 3, etc. And the corresponding path difference is 2n minus 1 lambda by 2. Now let us say coherent and incoherent sources. The resultant intensity is given by I1 plus I2 plus 2 root I1 I2 cos phi, and the term 2 root I1 I2 cos phi is called interference term. If phi is constant, then cos phi is constant, so the intensity will be constant. Then the sources are said to be coherent sources, and thus we can observe sustained interference. If phi is not constant, cos phi varies, and the average value of cos phi is 0, and the resultant intensity is I1 plus I2. Then the sources are said to be incoherent sources. Thank you.